for me, but the question was in the synthetic division if you're missing one of the terms.
Yeah, let's choose a problem. Any problem you would like to work on for the synthetic division first.
Okay. How about?
I didn't answer your question because I wanted everyone to have the chance to get in here.
There's x cubed minus 8x plus 2 over x plus 3.
Very good. So remember the few questions that I asked myself at the beginning. I'm asked to use the synthetic division. Second question is, are both top and bottom in descending order?
Yes.
Yes, they are. Is there a missing term from the top?
Yes.
Yes. So for the synthetic, and by the way, can I apply synthetic division?
Yes.
Yes, because the denominator is x plus or minus a number. So what goes in the box?
-3.
Good. Is this clear so far?
Yeah.
Okay, so then 1 for the coefficient of x cubed, the coefficient of x squared has to be 0. Coefficient of x is -8, and the free term is 2. Under 2, I will have to box in the remainder when I get there. The synthetic division always requires us to copy the first coefficient, no matter what that is. -3 times 1 is -3. I perform the operations I see without changing signs or anything because this was already taken care of here. So when I add, I get -3. Then I multiply these two and I get 9. I add what I see. So it's 1. -3 times 1 is -3. So then the answer is -1 in the box. I divide degree what by degree what? Degree 3 by degree. I always divide by degree 1 in the synthetic division, otherwise it's not going to work. I can't apply it. So when I divide degree 3 by degree 1, what degree do I get? 2. So please tell me what this is.
X squared minus 3x plus 1 plus -1.
Yes, that's correct. You can do that. That's
Okay.
fine. But I prefer writing negative in front.
Okay.
Now, you don't have to wait for anyone to tell you whether this is correct or not. How will you check? Here's a numerical question for you. How do I check that 10 divided by 3 is 3 integers plus 1/3?
3 times 3 plus 1.
Exactly. So x plus 3 multiplied by this minus 1 should give us what? If the answer is correct. Exactly what you just told me. You said 3 times 3 plus 1. What is that? Exactly. So this times this minus 1 should equal what?
X cubed minus 8x.
Exactly, the numerator. Exactly what you just told me with numbers. So let's do it. 1 minute. So please multiply this by this, subtract 1, and tell me whether you get the numerator. This is always the case. You don't need anyone. You don't need to look in the back. You don't need anyone to tell you yes, it's good or not. Is it? Is it true?
Yeah. Yeah. It is.
So we're done. Do I need to show anything here? Is this clear? Or do you need me to show you?
No.
Okay, very good. Next question. Lima, please. Can you choose one for the long division? Any problem? Just make it up.
Alright, so
Make it up. Anything.
x of
Say it again.
x of
Okay.
does Is the answer 5, 4, 3, 2, 1?
You can skip.
Or x is 5 4 x minus 3x squared minus 4
Very good. Over.
x squared plus 1.
Okay, very good. Can I use synthetic division on this?
Wait. No.
No, because the denominator does not have degree 1. Remember, the denominator must have degree 1. So I cannot use synthetic division, so I would use the long division. Can I use the first method? The very first one?
No.
No, because the denominator has 2 terms. I can only use the first one if the denominator has only 1 term. Very good. Good. So now my question is, are they in descending order?
Yes.
Yes. Are there missing terms from the top? I don't care about the bottom.
2 terms missing.
Very good. So please dictate. I will write x to the 5th, right? Plus x to the 4th,
And then space.
space, negative 3x squared, space, and negative 4. Yes, if you are comfortable with writing plus 0x cubed and plus 0x, that's fine too. Now, what happens if I don't need to use those spaces? That's fine. If I don't have to use them, I don't have to use them. But if I need them and they're not there, I mess up the problem. So always put them in there. If they are needed, we are going to use them. If they're not, that's fine too. So now x squared plus 1. First question, x squared times what is x to the 5th? Very good. Remember, I have to go back, distribute x to the 3rd to all terms, in this case to 2 terms, and write below like terms, not before I change the sign. So x to the 3rd times x squared is, but I have to write negative. X to the 3rd times 1. Right, and I change the sign. I cannot write it here.
Under the space.
Yes, I have to write it here. This is gone. I bring down the next 2 in line. X to the 4th and minus x to the 3rd. The next question. And you always remember, it will take a blink to check your answer. It's not difficult at all. Okay, so now x squared times what is x to the 4th?
X squared.
I need sign. You're right, but I need a sign because if I can't write x squared, right?
Plus positive.
Indeed, indeed. The sign is very important. Now I go back and distribute. X squared times x squared is
X to the 4th, negative under.
exactly negative x to the 4th. And then x squared times 1, but I have to subtract. And I cannot write it here. I have to write it here. Negative x squared. These 2 are gone. I bring down 2 more in line. Negative x cubed. And now I have to bring what?
So negative 4x squared.
Good. X squared times what? Careful. Equals negative x cubed. Thank you. Negative x times x squared. But I have to change the sign. Negative x times 1.
Negative x, which you have to change.
Yes, where do I write it? Not here. Right here. So positive x. And as you know, I always run out of room. So I did. So these 2 go away. I have to copy negative 4x squared because I haven't used it. And I have to copy plus x. Now here's a question for you. Is this the final question you think or not?
No.
It must be the final question. How do I know? 2 things. Two things. Power 3, power 2, power 1. There is nothing else but power 0. So it must be the last question. The second reason why I know it cannot be more than just one more step is that this degree is,
2.
and this degree is,
2.
so when I divide degree 2 by degree 2, I get degree
0. Okay.
0. So this must be the last question. X squared times what is negative 4x squared?
Minus 4.
Exactly. So you see, this is complete. There is nothing else left. I can't find another term. It doesn't exist. So negative 4 times x squared is negative 4x squared. I change. And negative 4 times 1 is negative 4, and I change. I cannot write another x. These two are gone. X has to stay. And what happens to negative 4 plus 4?
Zero.
Right, nothing here. So can anyone give us the final simplified form or the result of the division? And I'm going to say here, x cubed plus x squared minus x minus 4.
Plus x over x squared.
That's it. A much nicer problem than we could have found in the book. Thank you. Very nice. Okay, I don't trust my work. What do I do?
X squared plus 1 times x cubed plus that, yeah.
Let's try. Let's see if, and what do we have to get? If this is true, what do we have to get as the answer? This times this plus x. That's it. Let's give it a shot. Any questions on this? Any questions on this? Nico, are you clear what we are trying to do?
Yeah.
Okay. So it's the same thing with 10 divided by 3 equals 3 plus 1/3. 3 times 3 plus 1 has to give us 10. That's what we're doing. This times this minus 1 has to give us this. And then we know that the answer is correct. What I would like to do after this is finish up section 3.3. Give you just one theorem from section 3.4. And then look at the last section of chapter 3. I'm hoping that you can come on Saturday at 11. I would like to discuss the test if you finish up till then. Because I'll be here in this room. Is anyone interested? So that we don't spend time on Monday. I will post solutions anyway, but is anyone interested to show up at 11 on, so we can talk about the test?
I won't be able to make it.
Okay, it's fine.
Yeah, I don't think I can make it.
That's fine. That's fine. I will post solutions anyway. But I would like to go over the test with students who need to go over the test. Okay? Good. Did we get that?
Yes.
So this times this plus x, you obtain this?
Yes.
Any questions? Any questions? Okay, so we are back to section 3.3, dividing polynomials. There are two theorems here that I would like you to understand and carry with you to calculus. They're very important theorems, and you will see later why in calculus when we talk about limits. Okay. Let's look at x squared minus 1. We have an agreement on this, and I would like you to factor this for me. That's it. Now for a moment, please forget about it. And I'm going to ask you this question now. X squared minus 1 divided by x plus 1. What do you think the quotient will be? And what do you think the remainder will be? I'm more interested in the remainder than the quotient.
X minus 1.
Will be the quotient, awesome. And the remainder will be? Right. I know that. Because this is x plus 1, x minus 1, and I simplify, and I get the quotient as being x minus 1, plus 0 divided by x plus 1. How do I check this? This times this plus 0 has to give us this. Is it true?
Yes.
Okay. So this is number 1. I'm building the concept right now with you, together with you. So here's number 3. I have this polynomial. I'm back to the same situation. They're all 3 connected, deeply connected. Okay. So I name the numerator p of x, polynomial of x, x squared minus 1. And now I'm going to ask 2 questions. Without calculating, I want to ask you this. What do you think p of negative 1 will equal to? And what do you think p of 1 will equal to? And let me also add one more here. Let's say p of 3. And whatever. That's all I want you to say. 0, 0, and not 0. Why, when I replace in p of x, when I replace x by negative 1, I get 0. When I replace x by 1, I get 0. And when I replace x by 3, I don't get 0.
Because the negative, when you square it, becomes a positive.
Right, but that's what the polynomial says. But what do you think? What do you think happens here? Beyond just the implication that when I plug in and I square and I subtract, I get something else or I get 0. What do you think happens here? Why do I get a 0 when I plug in negative 1? And why do I get a 0 when I plug in 1 and not a 0 when I plug in 3? And I want you to think of x minus this and x minus this and x minus this. When I divide 9 by 3, what do I get?
3.
Why? Right, and because the remainder is? Right. So when I divide this polynomial by x plus 1, I get remainder 0. What does that mean? What does that mean about x plus 1? I'm looking for a word. Why, when I divide 9 by 3, I get 3 and the remainder 0? Because 3 is a,
Multiple.
you're close, a of 9. Factor, right? Or 9 is a multiple of 3, which is the same thing. But I was looking for the word factor. So why do you think when I plug in negative 1, I get 0? What do I have to say about x plus 1? It's the same thing as I say, 9 divided by 3 is 3 because 3 is a factor of 9.
X plus 1 is a factor of x squared.
That's it. This is the factor theorem. Very important theorem. Factor of x squared minus 1. What will you say about x minus 1? But careful, you are plugging in negative 1, right? It's the same concept from the synthetic division. What we put in the box, right? So x squared minus 1 has a remainder 0 when I plug in negative 1 in it because x plus 1 is a factor of x squared minus 1. What can you say about x minus 1? When I plug in the function 1, I get 0. Why? Because x minus 1,
Factor of x squared.
exactly, it's a factor of x squared minus 1. Now, please tell me what can you say about x minus 3? How come that when I plug in 3, I don't get 0?
It's not a factor.
Exactly. So that is the factor theorem. So I'll say not a factor of x squared minus 1. Therefore, when I plug in 3, I don't get 0. Just to make sure that this is clear, I'm going to say this. X cubed minus 1, let's say minus 8, divided by x minus 2. I'm asking you not to find the quotient. I'm asking you to find the remainder only of this division. How will you find the remainder of this division? And that's the remainder theorem now.
Use synthetic division.
Nope, I don't want the quotient.
Because it's still 0 because
What do I have to find?
the factors of x.
Nope, what do I have to find? It's exactly what I found here. What did I find here? In P of x, I plugged in what? Right. So what do I have to plug in x cubed? Exactly. Not negative 2. Yes. That's how I find the remainder. Just the remainder. Whatever that is. If the remainder happens to be 0, what will I say about x minus 2 again?
Factor
Of
x.
cubed minus 8. These are two very important theorems. I don't think that everyone gives them such a huge importance. They are very important. So since P of 2 is indeed 0, I will say x minus 2. So therefore, x minus 2 is a factor of x cubed minus 8. Very good. Okay, so let's look at few applications. We are still in 3.3. Use the factor theorem. So one more time, so let's put them in writing. So the factor theorem. And then the remainder theorem. Ready? I don't like the definition. I'm not testing on definitions, but let's put it in writing. C, little c, is a factor of P of x. IFF is a mathematical abbreviation, if and only if. Meaning it goes both ways. So what I write on the left of IFF implies what I write on the right. What I write on the right implies what I write on the left. So it goes both ways. IFF goes both ways. C is a factor of P of x if and only if.
C is a factor of p negative x.
So we can write this. X minus c is a factor of P of x if and only if.
P of c with
Thank you. You just got in. How did you know this?
great.
That does it. So both ways. If P of c is 0, it implies that x minus c is a factor of P of x. If x minus c is a factor of P of x, it implies that P of c must be 0. That's what it means. That's the direction. That's the way we use IFF. If and only if. It goes both ways. Okay, so that's the factor theorem. Now the remainder theorem. Maybe the door will protect us. Okay, so remainder theorem. The remainder of the division P of x over x minus c. As you notice, it's not x squared minus c. It's not x squared plus 1. No, it still has to be in tune with the synthetic division. Is how did we get it? Look at the above.
P of negative C negative P of negative x.
So is,
P of C.
that's it.
Oh, right.
Very good. Please remember these two theorems. They are very useful. Okay, so now let's look at a problem on page 252. Use the factor theorem to show that x minus c is a factor of p of x for the given values of c. Okay? Let's say 54. P of x equals x cubed plus 2x squared minus 3x minus 10, c equals 2. So we're asked to show that x minus c, which is x minus 2, is a factor or is not of this polynomial. What do I have to determine?
P of 2.
P of 2. What should P of 2 equal to in case x minus 2 is a factor of this polynomial?
0.
It should equal 0. If it does not equal 0, then what will I say about x minus 2?
It's not a factor.
It's not a factor of the given polynomial. So let's check. So this is 8. This is 8. 2 squared, 8, right? 8 plus 8 is 16. 3 times 2, negative 6. Negative 10. Is it 0?
Yes.
So I will say yes. Notice that these two theorems do not mention anything about the quotient. We only want to know whether a polynomial like x minus 2 or x plus 5 is a factor of something else, some other polynomial. We don't have the quotient. The quotient is not obtainable. Either with, I need this long division or synthetic division to find the quotient. This is only to quickly check whether this is a factor or not. And I can always go back and check my work, but not on the problem that we just did. How come that I cannot check on the problem that we just did? Because the denominator is not degree 1. But I can check on this one. The denominator is degree 1. So what do I plug in the polynomial at the top to only and only check my remainder? Exactly. So let's plug in negative 3 and check the remainder. What should the answer be?
0.
Why 0?
X plus 3 is a factor.
But it's not. So when I plug in this polynomial negative 3, what should I get? Right, that's the remainder. So if P of negative 3 does not equal negative 1, our answer is wrong. Although we know it's right because we checked it in a different way. So let's plug in this polynomial negative 3 and see if we get negative 1. If we don't, something is wrong. That's how I check the remainder. But only for something like this. I cannot do it here. So is the remainder negative 1? Good. Because the remainder is not 0. Obviously, x plus 3 is or is not?
Not a factor.
It's not a factor. That's why 3 is not a factor of 10. Because the remainder is 1. Did we get -1, everyone? Yes? Okay, very good. One more thing that I would like to mention here. Yes,
So what I
yes.
noticed is it has to be in the form x minus c. So that's why you made it negative.
Yes. Yes, exactly like with synthetic division. Yes. Other questions for me? Other questions? Okay. Every polynomial can be decomposed into factors. Any degree, any polynomial can be decomposed into factors degree 1 and degree 2, all of them. So any polynomial you can think of can be written as a chain of multiplications, of linear factors. If you don't want to use complex numbers, then you will say linear factors and quadratic factors. So any polynomial can be written like this. A, x minus the first solution, times x minus the second solution, times x minus the third solution, and I can go on forever, depending on the degree of the polynomial. If the degree is 5, how many factors should I come up with?
5.
Right? If the degree is 15, how many factors should I have? 15. Okay. Now, these solutions could be complex. So if you don't want to have complex solutions, then you will put these together into a quadratic term, quadratic factor. But all polynomials can be decomposed like this. And here's a problem. On the same page, 252, find the polynomial of the specified degree that has the given zeros. Zeros or x-intercepts or solutions, they all mean the same, right? Okay, so let's say 62 on page 252. We're given degree 5. The zeros are -2, -1, 0, 1, and 2. They're asking us to make up a polynomial. Now I have to caution you and say, we don't have any information about A. If you let A be any real number, then we will have infinitely polynomials with those zeros. Well, let's stick with the simplest possible polynomial, and let's say A is 1. They're not saying anything. So let's assume that A is 1. So can anyone give us the form from which I will be able to create the polynomial degree 5 with the given zeros?
X plus 2, x plus 1, x plus 0, x minus 1.
So this is how I determine a polynomial given the zeros. This is good enough. This is good, but it's not good enough in the sense that I have to show the polynomial degree 5. Here's how I'm going to multiply because of the agreement that we signed a long time ago. I'm going to multiply these two into x squared minus 1. You'll tell me how will you multiply these two into... That's it. Awesome. And now I'm going to put x in front, and then x squared minus 1, and then x squared minus 4. I will not touch x. X has to wait for me till I'm done with the binomials. So x in parentheses now, x squared times x squared, x to the 4th, x squared times -4, -4 x squared, and then negative x squared, and then plus 4. And of course, this is x in parentheses x to the 4th minus 5x squared plus 4. And only now I distribute the last factor, x to the 5th minus 5x cubed plus 4x. Now, I'm going to ask you, what are the zeros of this? How many solutions will you give me?
5.
And what solutions will you give me?
Negative 2, negative 8.
Of course. Okay, I couldn't trap you. Thank you. I didn't want to either. Good. Any questions? When it comes to solving equations degree 1, we are very powerful. When it comes to solving equations degree 2, polynomial equations degree 2, we are very powerful. When it comes to degree 3 or 4 or 5, we don't have power. We have some theorems, but we don't have a quadratic formula for degree 3, 4, 5. We don't have a way. We just hope that they are factorable. But if they're not factorable, we have no clue what to do. There is a theorem that I would like to talk about briefly, and then we move on. It's called the rational zeros theorem. This is in section 3.4. I just want to mention this theorem and show you an example, because it's a powerful theorem. There are a lot of other theorems, but I think this is the most important one. And I'm not going to show other theorems, just this one. And I'm going to illustrate it with an example. So let's look on page 261. Page 261. And we can choose any problem you would like from 15 through 56 on page 260. Which one?
42.
Actually, I was just looking at 42. That's funny. Okay, 42. P of x equals 6x to the 4th minus 7x cubed minus 12x squared plus 3x and plus 2. I don't care about what the problem is asking us to do. I do care about two things. I want to find all solutions if possible. How many am I looking for?
4.
Very good. Yeah, degree is 4. Degree is 4. So I'm looking for 4 solutions. And I also want to present the factored form of this polynomial. What do I mean by that? And I will have 1, 2, 3, 4 factors. The leading coefficient, I don't know. I'll have to see. Okay. Good. This polynomial may be factorable, but I have no idea how to factor it. It is possible that it's factorable, but I have no clue how, not even where to start. Okay? So the rational zeros theorem, what is a rational zero? 10 is a rational zero. It's 10 over 1. 1/2 is a rational zero, a ratio. 2/3 is a rational zero, and so on and so forth, including integers, right? So if this polynomial, that's the theorem, if this polynomial has rational zeros, they will be on the following list. The last coefficient, of course, it has to be in descending order. Last coefficient over the first coefficient. So 2 over 6. Okay. I looked at 2 and I looked at 6. So I'm going to write this down now. If P of x has rational zeros, they will be definitely, if a solution is the square root of 3, I don't know how to find it. The square root of 3 is not a rational number. But if it has 1/2, 2/3, negative 1/5, 5 over 1, 10 over 1, 3 over 1, yes, I will find them with this theorem. So if p of x has rational zeros, they will be on this list. Here's the list. What are the divisors of 2? Yes. Plus or minus 1, plus or minus 2. What are the divisors of 6? Plus or minus 1, plus or minus 2, plus or minus 3. That's it. So how many would I have to check? All till I find, hopefully, till I find 4. Once I find 4, I don't care about the rest. It cannot have more than 4 solutions, right? So here's what I have to punch in the calculator. 1 over 1, comma, 1 over negative 1, comma, 2 over 1, comma, 1 over 2, comma, 1 over 3, comma, 1 over 6, comma, 2 over 3, 2 over 6. In the hope that I get 4 zeros, right? When I plug this number in the polynomial by the remainder theorem, if I get 0, they are factors. So with the calculator, believe it or not, I'm ready with it. Are you proud of me? Okay, in y equals, let's punch in this 62. 6x to the 4th minus 7x cubed minus 12x squared. I know you're ahead of me because I have to find these keys. Plus 3x plus 2. Don't start, just give me 1 second to get there. Go back to second. I have to go back to the table set. It resets automatically for me. Okay, so go back to second and table. So I check 1, because 1 over 1, I check 1. Then I check 1 over negative 1, which is negative 1. Now I check 1 over 2, 1 divided by 2. Now I check negative 1 divided by 2. Then I check 1 over 3. Then I check negative 1 divided by 3. Then I check 1 over 6.
Yeah, I'm getting like -8 and 0 and 0.
Yeah, that's what I'm getting to.
Okay, so I plugged in something else? Oh, I'm very good at that.
Oh.
Oh, I did plug in something
Times
else.
negative 7x.
Yeah.
Oh. How did this parenthesis pop up in there? I didn't put a parenthesis.
I think it was part of it.
Ah, possibly. Okay. Okay. Thank you. So for 1, I got for negative 1.5, negative 0.5. So did you get any zeros?
Yeah, for -1
Okay.
and
1.
-2.
So 1, negative 1. Negative 0.5. 0.5.
I think it's still showing the multiple versions.
Yeah, that is.
It's probably.
I just deleted it, didn't I?
It's probably a
says
negative
times
instead of a minus.
Yeah, I just deleted it.
Yeah, it came back because it was a negative instead of a minus.
Okay, so I don't need to show anything. So tell me what was the first one. That's even better. What was the first solution?
Negative 1.
-1. The second solution that we got.
1 over 2.
The third solution. So you have to continue with 1 over 6. And then 2 over 1. You don't have to do this one more time because we already have it 1 over 1. But you have to do 2 over 3 and 1 over 3, which we already had.
Oh, I get 2. 2 over 1 is right.
Okay, is the third solution 2?
I got negative 1 over 2.
Is it? Okay. Do we have a fourth solution?
Negative 1 over 3.
Awesome. So this was possible because of the rational zeros theorem. Otherwise, we would have been totally lost. So now I'm ready to write the polynomial. x minus the first solution, x plus 1. Of course, I have to write the a. So that's the 6. A equals 6. Then the next one will be
X.
X plus
minus 1/2. The first, x minus the first solution, x minus the second solution. Okay, so then x minus 2, and then x plus 1/3. Any questions? It's a very powerful theorem. Very powerful. What if, here's a quick question before we move on. What if I had gotten just these two?
I wouldn't have, work.
Nope. So let's say I don't have these. But I got the solution x equals -1, and I got the solution x equals 1/2. Here's what I do. Nope. I'll come back to it in a second. So I only know that I have a solution x equals -1, which means a factor of x plus 1. And I know that I have a factor of x minus 1/2. I don't have the other two. How do I determine the other two? Like, for example, my calculator ran out of battery. I don't-
Or do you have 2 would just be x squared?
Exactly. Exactly. That's the idea. Here's how I would do it. So in the box, I will put -1. Then I will copy my polynomial coefficients, 6, -7, -12, 3, and 2. And I will determine the polynomial removing this factor. I will determine this. So 6, -6, -13, 13, 1, -1, 2. What should the remainder be?
0.
Of course, because I know that x plus 1. Okay, and -2, and I have 0. Now I know that I can continue. I'm going to continue with a different color. I will continue with what?
Negative.
Not negative.
And 1/2.
Yes, very good. So let's see. What should the remainder be when I'm done?
0.
Yes, because I already know that x equals 1/2 or x minus 1/2 is a factor. Good. I bring 6 down. 1/2 times 6, 3. -13 plus 3, -10. 1/2 times -10, -5. -5 is -4. 1/2 times -4 is -2. So I know now, which I did not know before, that this product is this. This is the 6x squared minus 10x minus 4. And that I know how to solve. I'll set it equal to 0. I use the quadratic formula, and I get the other two factors. I'm sorry?
How do you get this?
Which one?
The 6x squared minus 3.
When I divide degree 3 by degree 1, I get degree 2. 6x squared minus 10x minus 4.
Yeah, okay.
What happens when it's a little bit more difficult is when a solution appears twice or 3 times. Then I have to do this with that solution twice, or maybe 3 times. Because I may have one solution -1 and the other one 1/2. But this may appear more than once. So then I have to continue dividing with x minus 1, by x minus 1. So I just want you to have the idea of the rational zeros theorem.